The National Electrical Code, specifically Section 250.53 states that the continuity of the grounding path or the bonding connection to interior piping shall not rely on water meters or filtering devices and similar equipment. This means that a jumper is required for the bonding connection to the interior metal water piping regardless of the grounding electrode conductor connection. The bonding connection, as described in National Electrical Code Section 250.104, is intended to ensure that all exposed metal parts of electrical equipment, metal raceways, and enclosures are connected to the grounding electrode system. This connection is essential for preventing electrical shock by providing a low-resistance path for fault current to flow to ground. The grounding electrode conductor connection, described in National Electrical Code Section 250.53, is intended to provide a low-resistance path for fault current to flow to earth. This connection helps protect equipment from damage and personnel from injury. In the scenario described, the bonding connection is required to ensure that the interior metal water piping is connected to the grounding electrode system. This connection is not dependent on the grounding electrode conductor connection. To further elaborate on the requirements surrounding water piping and grounding and bonding, let's delve deeper into the specific sections of the National Electrical Code. Firstly, consider the purpose of bonding. Bonding aims to create an electrically conductive path that connects all metallic parts that are likely to become energized during a fault. This equipotential plane ensures that voltage differences between these parts are minimized, thereby reducing the risk of electric shock. Secondly, the grounding electrode system serves as the reference point for the electrical system, connecting it to the earth. This provides a path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to operate and clear the fault. In the context of water piping, the National Electrical Code recognizes that water meters and other similar devices can introduce discontinuities in the metallic water piping system. These discontinuities can interrupt the bonding path and compromise the effectiveness of the grounding electrode system. Consequently, the code mandates that a bonding jumper be installed around these discontinuities to maintain the continuity of the bonding path. This ensures that the entire water piping system is effectively bonded to the grounding electrode system, providing a safe path for fault current. Let's examine the specifics of National Electrical Code Section 250.53 in greater detail. This section explicitly states that the continuity of the grounding path or the bonding connection to interior piping shall not rely on water meters or filtering devices and similar equipment. This is a critical requirement because water meters and filtering devices are often made of materials that are not electrically conductive or that have a high resistance to electrical current. If the grounding or bonding connection were to rely solely on these devices, the effectiveness of the grounding electrode system would be compromised. The bonding jumper provides an alternative, low-resistance path for fault current to flow, ensuring that the water piping system remains effectively bonded. Furthermore, it's important to understand the distinction between grounding and bonding. Grounding refers to the connection of the electrical system to the earth, while bonding refers to the connection of metallic parts within the electrical system to create an equipotential plane. While both grounding and bonding are essential for electrical safety, they serve different purposes. Grounding provides a path for fault current to flow back to the source, while bonding minimizes voltage differences between metallic parts. In the case of water piping, both grounding and bonding are necessary. The water piping system must be connected to the grounding electrode system to provide a path for fault current to flow to earth. Additionally, the water piping system must be bonded to other metallic parts within the electrical system to minimize voltage differences and reduce the risk of electric shock. To further clarify the requirements for water piping and grounding and bonding, let's consider some practical examples. Imagine a scenario where a fault occurs in an electrical appliance that is connected to a metallic water pipe. If the water piping system is not properly grounded and bonded, a fault current could flow through the water pipes, potentially energizing them. This could create a dangerous situation for anyone who comes into contact with the water pipes. However, if the water piping system is properly grounded and bonded, the fault current will flow through the grounding and bonding conductors back to the source, tripping the circuit breaker and clearing the fault. This will prevent the water pipes from becoming energized and protect people from electric shock. In another scenario, imagine a situation where there are multiple metallic water pipes within a building. If these water pipes are not properly bonded together, voltage differences could develop between them. This could create a potential shock hazard for anyone who comes into contact with two or more of the water pipes simultaneously. However, if the water pipes are properly bonded together, the voltage differences will be minimized, reducing the risk of electric shock. To ensure compliance with the National Electrical Code requirements for water piping and grounding and bonding, it is essential to follow these best practices. Firstly, always install a bonding jumper around water meters and other similar devices. This will maintain the continuity of the bonding path and ensure that the water piping system is effectively bonded to the grounding electrode system. Secondly, use appropriately sized grounding and bonding conductors. The size of the conductors should be determined based on the size of the electrical system and the available fault current. Thirdly, ensure that all grounding and bonding connections are made properly. Connections should be clean, tight, and corrosion resistant. Fourthly, inspect grounding and bonding connections regularly. This will help to identify and correct any problems before they become a safety hazard. By following these best practices, you can help to ensure that the electrical system is safe and reliable. It is also important to note that the National Electrical Code is a complex document, and it is essential to consult with a qualified electrician to ensure compliance with all applicable requirements. The electrician can provide guidance on the specific requirements for your installation and help to ensure that the electrical system is safe and reliable. In summary, the National Electrical Code requires that a bonding jumper be installed around water meters and other similar devices to maintain the continuity of the bonding path and ensure that the water piping system is effectively bonded to the grounding electrode system. This requirement is essential for electrical safety, as it helps to prevent electric shock and protect equipment from damage. By following the best practices outlined above and consulting with a qualified electrician, you can help to ensure that the electrical system is safe and reliable. In addition to the general requirements for water piping and grounding and bonding, there are also some specific requirements that apply to certain types of installations. For example, in healthcare facilities, the National Electrical Code requires that all metallic water pipes be bonded to the grounding electrode system. This is because healthcare facilities are particularly vulnerable to electrical hazards, and it is essential to minimize the risk of electric shock to patients and staff. Similarly, in industrial facilities, the National Electrical Code may require that additional grounding and bonding measures be taken to protect against electrical hazards. This is because industrial facilities often have a high concentration of electrical equipment, and the risk of electrical faults is greater. To determine the specific requirements for your installation, it is essential to consult with a qualified electrician who is familiar with the National Electrical Code. The electrician can assess the specific hazards present in your installation and recommend the appropriate grounding and bonding measures. It is also important to note that the National Electrical Code is not the only standard that may apply to water piping and grounding and bonding. Other standards, such as those published by the American Water Works Association and the National Fire Protection Association, may also contain requirements for water piping and grounding and bonding. To ensure compliance with all applicable standards, it is essential to consult with a qualified engineer or consultant who is familiar with these standards. The engineer or consultant can review your installation and provide guidance on the applicable requirements. In addition to the technical requirements for water piping and grounding and bonding, there are also some administrative requirements that must be followed. For example, many jurisdictions require that electrical installations be inspected by a qualified inspector before they are put into service. The inspector will verify that the installation complies with the National Electrical Code and other applicable standards. To ensure that your installation is approved by the inspector, it is essential to follow all applicable requirements and to maintain accurate records of the installation. This will help to demonstrate that the installation is safe and reliable. In conclusion, The National Electrical Code requires that a bonding jumper be installed around water meters and other similar devices to maintain the continuity of the bonding path and ensure that the water piping system is effectively bonded to the grounding electrode system. This requirement is essential for electrical safety, as it helps to prevent electric shock and protect equipment from damage. By following the best practices outlined above and consulting with a qualified electrician, engineer, or consultant, you can help to ensure that the electrical system is safe, reliable, and compliant with all applicable requirements. Furthermore, remember to continuously update your knowledge on the National Electrical Code, as it undergoes revisions and updates periodically. Staying informed about the latest changes and interpretations of the code is crucial for maintaining safe and compliant electrical installations. Engage in continuing education courses, attend industry seminars, and consult with experienced professionals to ensure that you are up to date on the latest requirements. Remember that electrical safety is paramount, and a thorough understanding of the National Electrical Code is essential for protecting people and property from electrical hazards. In addition to the specific requirements for bonding jumpers around water meters, it is also important to consider the overall grounding and bonding system for the entire building. A well-designed and properly installed grounding and bonding system is essential for minimizing the risk of electric shock and equipment damage. The grounding electrode system should be designed to provide a low-impedance path to ground for fault current. This can be achieved by using a combination of grounding electrodes such as ground rods, ground plates, and underground water pipes. The bonding system should be designed to create an equipotential plane throughout the building. This can be achieved by bonding together all metallic parts that are likely to become energized during a fault, such as metal conduits, metal enclosures, and metal water pipes. The grounding and bonding system should be inspected regularly to ensure that it is functioning properly. This can be done by visually inspecting the connections and by performing electrical tests to verify the continuity of the grounding and bonding paths. If any problems are found, they should be corrected immediately. In addition to the technical aspects of grounding and bonding, it is also important to consider the human factors. Electrical safety is a shared responsibility, and everyone should be aware of the potential hazards associated with electricity. Electrical safety training should be provided to all employees who work with or around electrical equipment. This training should cover topics such as the proper use of electrical tools, the dangers of working with energized equipment, and the procedures for reporting electrical hazards. Warning signs should be posted in areas where electrical hazards exist. These signs should clearly identify the hazards and provide instructions on how to avoid them. By taking a proactive approach to electrical safety, you can help to create a safe and healthy work environment for everyone. Finally, remember that electrical work should only be performed by qualified individuals. Electrical work can be dangerous, and it should only be performed by people who have the training and experience necessary to do it safely. If you are not qualified to perform electrical work, you should always hire a licensed electrician. A licensed electrician has the knowledge and skills necessary to perform electrical work safely and in accordance with all applicable codes and standards. By hiring a licensed electrician, you can be sure that your electrical work is done right and that your property is protected from electrical hazards. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before making any decisions about electrical installations. The NEC requirements mentioned are based on the 2017 edition. Always refer to the latest edition of the NEC and local amendments for specific requirements in your area.